Here are those ACL numbers we were discussing in the previous video, and you can see at the top here are our original ranges 1 through 99 for standard, 100 through 199 for extended, and then you'll note the expanded ranges here, 1300 through 1999 for the standard, then 2000 through 2699 for expanded. Again, definitely something you want to watch in multiple choice practice exam questions and of course real exam questions. Now, those are not the only ACL numeric ranges there are. If you've run this on certain other routers, it really depends on the model and the iOS you have as to which ones you have available. Let me show you a full list actually from Cisco's website. And they've got the ones we're familiar with, but boy, I mean, they've got XNS, DECnet. You can see all these ones that are in the middle that particular router isn't running. Extended XNS, then AppleTalk. Here's an IPX and then an extended IPX range, then a SAP range, no jokes please, and Vines is even in there. So it just depends on what iOS you're running. It doesn't mean that you have a bad router or something. If you run that command and you don't see every single ACL numeric range, that's going to be pretty rare, and especially since we are most concerned right now with those standard and extended ACLs. So let's go ahead and bring that down, and I want to mention the wildcard mask here. I know we've got that one video for you to watch. Well, let's go over the details of that wildcard mask one more time, because we're going to use those in all of our ACLs, and they determine what part of a network number should and should not be examined for matches against the ACL. They're basically bizarro subnet masks. They're like inside-out subnet masks, because the ones and the zeros in a wildcard mask mean the exact opposite of what they mean in subnet masks. Zeros indicate to the router that this particular bit must match, and ones are used as I don't care bits. The ACL doesn't care if there's a match or not. And in this example, all packets that have a source IP address on the 196.17.100/24 network should be allowed to enter the router's Ethernet 0 interface. No other packets should be allowed to do so. And really, this gives you a good visual, because in essence, in this way, when we're permitting and denying traffic, the ACL is kind of a traffic light. You know, it's either stop, go, except we're using permit or deny. So here, you could probably do this one right in your head, especially if you've gotten some binary practice in. And what we need to do is write an ACL that allows packets in if the first 24 bits match 196.17.100 exactly. And then we want the ACL to not allow packets sourced from any other network. And this is what we end up with. The first octet, second octet, third octet, all bits must match. We really love it when it's even like that, when it ends after an octet. You know, you don't even have to write this one down most likely. And the fourth octet is all I don't care bits. You know, so we are saying with this mask that there's a match if the first three octets exactly are 196.17.100, and then after that, hey, I don't care. Here's your resulting wildcard mask from the first octet down, and it's going to be 0, 0, 0, 255. I have the binary math chart on the board for you as well, but I know you can look at that at this point in your studies and just say, bang, you know, I know exactly what that is. So the wildcard mask is 0, 0, 0, 255, and again, I know I've mentioned this a couple times, and when you're taking those practice exams out there, watch this, because you don't want a mask. It's really easy to look at a mask and say 255.000, that's what I want. Not if you're writing an ACL, because you're using wildcard masks, and what you mean is to have a wildcard mask of 0, 0, 0, 255. Now, wildcard masks are not only important for ACLs, they're also important for your OSPF and EIGRP configs. And here in the CCENT portion of the course, of the CCENT course, I should say, we do a little bit of OSPF. So we need to be ready to do this kind of thing. Consider a router with the following interfaces. And we've got 172.12.12 for each one, and then it's .12 for serial 0, and then .17 for the fourth octet in serial 1. The wildcard mask is going to require the first 28 bits to match 172.12.12.0. The mask doesn't care what the last 4 bits are. Can you do that one in your head yet? I bet you can, and I really don't mean to sound like you know who, but I bet you can, because here we go. The first 4 bits of that last octet have to match, and the last 4 don't, so those are the ones. So if we have all zeros for the first 3 octets and then 0, 0, 0, 0, 1, 1, 1, 1 for the last octet, that is going to add up being what? 15. because we have the 1 bit set for the 8, 4, 2, and 1 bits. So converted to dotted decimal, it's 00015. Again, practice is the key. You can watch me do it all you want. You can listen to my dulcet tones all you like, but you've got to get that piece of paper out and that pen or pencil out and do it on paper, and it's amazing how quickly you develop this skill. Right now, let's configure our first ACL, and we'll start doing some applying here. Let's quickly go over the ACL theory that we learned in the first video, though, because we got to have this down cold. Standard ACLs consider only the source IP address for matches. The ACL lines in a standard ACL, just like every other ACL, are run from top to bottom until we get a match. If we don't get a match, that implicit deny at the bottom and the end of every ACL is going to deny traffic. So again, if packets are not expressly permitted, they are implicitly denied. So let's take a look at what an ACL would look like if we were working with router 3, which I believe is the one we're on. If not, we can get there. And we're going to configure an ACL that would permit packets with a source IP address of 172.12.12.0/24. So anybody on that particular subnet, the packets will be accepted and everything else will be denied. And there we are in router 3. So let's actually start that, and we'll just go with 1 here. And we use iOS help to go across. We're already at the deny permit choice and remark. We're going to talk about that later. It's self-explanatory, but we're still going to talk about it for a minute. And let's see, we're going to permit then. And we've got some interesting choices here. You know, we've got host name or ABCD address to match. We also have any and host. We're getting to those later in this part of the course. Right now, let's go with 172.12.12.0. Wildcard bits makes sense. It's even telling us it's a wildcard mask. Also, log matches against this entry. If you want to keep a log of your ACL hits, you can do that, and just by putting the word log at the end of a particular line. And then when you do show access list, it's going to show you how many times that ACL matched against packets. We're just going to go with the wildcard bits, and that's going to be 0000255. And then you still have the option to log against that entry, or you could just create it. So that's our first line of our ACL. Do we need a second line to do what we talked about doing? We do not, because we said we just want to permit packets that are sourced from 172.12.12.0/24. That's what we've got. And we have the implicit deny, so we're all set. But sometimes you're going to see an ACL where people write the deny out. Let me show you what I mean here. That any looks pretty good, so I'm going to use any right there. Now, why would I ever write a deny any statement at the end of an ACL when I know there's one there anyway? I know the implicit deny is there. One reason is the visual. Some people just like to write it just so people also who come behind them and might forget about the implicit deny won't look at their ACLs and say, oh, this guy screwed up. You've got to put a deny any at the bottom. So some people just like the visual, and that's fine. The real productive reason for using it, though, is to log your denies. The implicit deny is not going to be logged in any way. If we want to if we want to log our deny any's at the end of an ACL, you would need to write it out and then actually put the word log here at the end. So it's not a requirement in any way, shape, or form, but that way when you look at show access list, you can see how many times that deny any actually came into play. So that's really it. We've written this access list, and so now what do you want to do? We need to apply it. Don't forget this part. Sometimes, especially when you're starting, because you're concentrating so much on the binary, and you got your wildcard mask down, and you got your ranges down, you got all that down, but you've got to apply it. It's not doing anything right now. It's just sitting in the config. We have to apply it to the interface with the IP access group command. Let's go ahead and bring that back up. And see, I mean, the more you use iOS help, the more commands you see. But the one we need is right at the top. Access group, specify access control for packets. So let's put access group there. And you can see it's asking, it's even telling you, the router is kind enough to tell you what these ranges are. I wouldn't count on the exam telling you, I would know them. So it's saying, okay, do you want to do this range, or do you want to do that range, or, or word? Well, that's if you give the access list a name. And we are going to see, we're going to do a lab with that. I want you to see that. Maybe a little beyond the CSENT scope, but I want you to see a named ACL. As a matter of fact, I think they'll be on there. So right now, though, we're going to stick with what we've done so far, and we numbered that 1. And we're not done. Notice that it does not say CR here. IP access group followed by the number is not enough. You have to say, I want this applied to inbound packets, or I want it applied to outbound packets. You have to define that. So we did say in during our little drill, and that is it. That would be it right there. IP access group 1N. And again, we saw the N at the end because you've got to indicate to the router whether that ACL should be applied as packets come into the interface or as they are queued to leave the interface, that being out. They are not technically in the queue yet when they're stopped by an outbound ACL, by the way. They're actually between the routing engine and the transmission queue. But we just know that they're not leaving. That's what we're concerned with right now. Overall, again, let's quickly review that. Using an ACL to deny or permit traffic at the interface level, it's a two-step process. Write your ACL and then apply it with IP access group. And again, we have to specify whether that is inbound or outbound. And right here, using the ACL we just wrote, traffic source from 172.12.12.0/24 is going to be accepted. And all other traffic, it would have been stopped by the implicit deny. I put an explicit deny in there to show you the log option. And this all happens as the packets enter the router on E0. Again, the way I've always remembered this, if traffic is not explicitly permitted, it is implicitly denied. A great way to remember your rules. We are going to talk about remarks on the next video, and I'm sure we'll talk about something else too. What kind of remarks? Come around to the next video. I'll see you there. We'll talk about it then.